Okay, today we have 5 examples. What we're doing today is this on the top of your paper that we are solving systems using 3 methods. And we're using the 3 methods that we have already learned so far in Unit 2. The first day, we solved the system by graphing, so that's what we'll be doing on problem 1. Day 3, which is on Friday, we solved systems by elimination, so that's the second method. And yesterday we learned method number 3, which is solving a system by substitution. So today is just a review of everything we did last week, as well as what we did yesterday. So problem number 1 is to solve by graphing. Now, in order to graph those 2 lines, you have to have y by itself. So do we have y by itself? No. So let's start with that first equation. The first equation is x plus 2y equals 4. Now, if I want this y by itself, what has to move? The x. I'm going to circle the x, draw an arrow showing I'm moving it. And what happens to x when I move it to the other side? Negative. Changes to a negative x. Now the 4 is positive, so it stays positive. Now we have to get rid of the 2 out front. How do we get rid of that 2 out front? Divide it all by 2. So that gives us y equals, what number is in front of this x?
1.
Negative 1. So what fraction do you see? Negative 1/2, so there's our slope. And what's 4 divided by 2? 2. So that first equation is ready to graph. Now we need to do the same process to the second equation. So that one is 2x minus y equals 3. And if I want this y by itself, what has to move? 2x. What happens to that 2x when I move it to the other side? Becomes a negative 2x. Be careful. What's in front of that y? A negative 1. So make sure you bring down that negative with the y. Some of you are forgetting to do that. And how do I get rid of that negative in front of the y? Divide everything by negative 1. So that gives us y equals negative divided by negative becomes positive 2x. And what's 3 divided by negative 1? Negative 3. Okay, so now we're ready to graph both of those lines. So back to the first one. What is the y-intercept? 2. And remember from last week we said slope is rise over run. So if I rise negative 1, does that mean I go up 1 or down 1? We need to go down 1, right 2, down 1, right 2. Now what's the opposite of down 1, right 2? Up 1, left 2. And for the second line, over here in red, what is the y-intercept for this equation? Negative 3. And slope is rise over run, so this is actually 2 over what number? 1. So we need to rise 2, run 1. So if the rise is positive, then do we go up or down? Up. So we need to go up 2, right 1, up 2, right 1. And the opposite of up 2, right 1? Down 2, left 1. And when we're looking for a solution, how do you recognize the solution?
When they intersect.
Yeah, the point where they intersect. So they intersect right here. And what is that point written as an ordered pair? 2, 1. Make sure you have parentheses around your ordered pair. Some of you are forgetting to do that on your assignment. Okay, so that was method number 1, solving a system by graphing. Looking at problem number 2. Number 2 says to solve by elimination. Remember, for elimination, x and y have to be on the left. Our constants have to be on the right. So, do you see a 0 pair with x and y? No. Do you see one that
Can you go back?
would be easy? Yes, I can go back. Okay, you good? Okay, so this is an elimination form because X and Y are on the left and the constants are on the right. But do you see a zero pair? No. Is there one that we could easily make a zero pair? No. No, because they both have numbers in front. So if that's the case, we'll have to flip the numbers. So that means both equations will have to be distributed. So what we'll have to decide, do we want to eliminate the x's or the y's? Yeah, I would work with the x's. First of all, they're positive and they're smaller numbers. So notice if I look at the coefficients, the top x has a 2 out front. That is what the bottom equation needs to be multiplied by. So the top coefficient, move it down, and the bottom coefficient, the 3, move it up. So what you need to do is split the coefficient. So the top coefficient, the 2, goes to the bottom, and the bottom coefficient of 3 goes to the top. Now let me check it to see if we'll have a zero pair. What is 3 times 2x? 6x. And what is 2 times 3x? 6x. So are those a zero pair right now? One of them is positive 6x. What does the other one have to be? A negative 6x. So that means one of these needs to be a negative out front. I would just make the smaller one be the negative. Okay, so now we're ready to distribute. So the top equation, distribute a 3. So what's 3 times 2x? 6x. What's 3 times negative 7y? Negative 21y. Even the answer gets multiplied, and what is 3 times 8? 24. Bottom equation, distribute a negative 2. What's negative 2 times 3x? Negative 6x. And what's negative 2 times negative 4y? Positive 8y. And negative 2 times negative 1? Positive 2. Now do you see a zero pair? Yes. Yeah, positive 6x, negative 6x. There's a zero pair. Combine your y with negative 21y plus 8y.
29y.
Well, this one's a negative 20.
Oh, okay.
Negative 13y. And 24 plus 2. 26. How do I get rid of that negative 13? Divide both sides by negative 13. And what does y equal? Negative 2. Now, that's half of the answer. To get the other half of the answer, we need to pick. Do we want to use the top original or bottom original? Top. 2x minus 7y equals 8. Instead of the y, what do I replace it with?
Negative 2.
Negative 2. And when I multiply those, what's negative 7 times negative 2?
14.
Positive 14. What's next? Subtract 14 to both sides. What is 8 minus 14? Negative 6. Divide both sides by 2. X is negative 3. Now I need to make sure I write my answer as an ordered pair. So what would my answer be as an ordered pair? Negative 3, negative 2. Make sure it's written as an ordered pair. Okay, so that was method number 2. That was the elimination method, where you make a zero pair with one of your variables. Here is method number 3. This is what we did yesterday. We solved by substitution. Now for substitution, you have to have a variable by itself. And what variable is by itself? The y. And what do I circle? plus 6, and I draw my arrow to which variable? To the y. Then rewrite the bottom equation, so this will be x minus 2. What's being replaced? Put it in parentheses. Yes, the y is being replaced with a negative x plus 6, and this equals negative 6. Now we need to distribute that negative 2. So we have an x. So what's negative 2 times negative x?
Positive 2.
Positive 2x. And what's negative 2 times 6?
Negative 12.
Negative 12 equals negative 6. What's next?
Yeah.
Combine your like terms, so 1x plus 2x is 3x. Minus 12 equals negative 6. What's next? Add 12 to both sides. So 3x equals, what's negative 6 plus 12? 6. Divide both sides by 3, what does x equal? 2. There is half of the answer. To get the other half, make sure you use one of the original equations. So do you want to use the top original or bottom original? Top. Y equals negative x plus 6. Instead of x, what do I replace it with? 2. And what's negative 2 plus 6? 4. So what is my final answer? 2 4 is right. Make sure you write it as an ordered pair. Ordered pairs have to have a parentheses. Okay, next one. So those were the 3 methods: graphing, elimination, and substitution. Now it says we can solve by any method. So looking at number 4, what method is this set up for? Elimination. Remember, elimination, they have to be in standard form. Ax plus by equals c. Are both of those in standard form? X and y on the left, constants on the right? Yes. Now, if it were substitution, there would be a variable by itself. And do we have a variable by itself? No. So this one is set up already for elimination. So let's do elimination. So do we want to eliminate the x's or the y's? X or y? X. So if this is a positive 3x, what does the top one have to be? Negative 3x. So what does the top equation have to be multiplied by? Negative 3. Okay, I want you to do number 4. I want you to solve that by elimination. Where's number 3? Just let me see. Where's number 1? I need help. No, you need to rewrite the bottom one, and then combine those equations together. So combine the x's, combine the y's, and combine the 4. What's your question? Do I do that concept? Yeah, you see negative 3 times y, and negative 3 times 2.
So would it be negative 3y equals negative 3 times 2, right?
I'm just gonna take my own way, right?
Here, negative 3 times 2, negative.
Yeah, what? I have 3. Okay, you're already doing it. And I got 31.
Here, negative 3y, positive 2y, is negative 2.
Only all that.
No, there should be negative 1y, equals negative 1, then divide by negative 1. Yeah, y is negative. So it should be positive. That says negative r equals negative 1. And then divide by negative 1. So it becomes positive. Top or bottom, either one, whichever one you read.
You just get a walkie talk. Need yours?
Here, negative 3 and times 2, that should be negative 6. I have paper towels, let's do it. Okay, let's look at number 3. No, not number 3, number 4. Okay, make sure all 3 of these were multiplied by negative 3, so negative 3 times x is negative 3x. Negative 3 times y is negative 3y. And negative 3 times 2, negative 6. Bottom equation stays the same, 3x plus 2y equals 5. Where's the 0 pairs? Negative 3x, positive 3x, it goes away. Be careful, what's negative 3y plus 2y? Negative 1y. And what's negative 6 plus 5? Negative 1. Right, we need to get rid of the negative 1 out front. Divide both sides by negative 1, and the answer becomes positive 1 for y. Now to solve for x, go back to the original. Do we want to use top original or bottom original? Top. So x plus y equals 2. Replace the y with what number?
1.
A 1. Subtract 1 to both sides. What is the answer for x?
X equals 1.
X is 1. Am I finished?
Yes.
No.
Oh, stop me, sorry.
Write your answer as an ordered pair. So what is our answer as an ordered pair? 1, 1.
Substitution on this one.
You could have done substitution on this one, but you would have had to get a variable by itself. So yeah, you could have done substitution. Okay, number 5. Is this one set up for elimination? X and Y on the left, constants on the right? No. Is it set up for substitution? Do we have a variable by itself?
No.
Not yet, but we could get a variable by itself. What variable could we get by itself? The y. So how do I get rid of the 16? Divide everything by 16. So the top equation is staying the same. 25x equals 91 minus 16y. Bottom equation needs to be divided by 16. So 16y divided by 16 is just y. 64 divided by 16 is 4. And negative 16x divided by 16 is negative x. Now is it ready for substitution? Do you have a variable by itself? Yes. So what do I circle? The 4 minus x, and I draw my arrow to what variable? To the y. Okay, I want you to do number 5 using substitution.
So it's still a lot.
Yes. So the 100 negative 16, but that is ready.
Where are you at?
Yes, and negative type the negative 3 Okay, for this one, we are replacing the y with 4 minus x. So bring down the 25x, the equal sign, the 91, minus 16. What's being replaced goes in parentheses, and what are we replacing the y with? 4 minus x. Distribute your negative 16. And what's negative 16 times 4? Negative 64. Oh, it's negative 16 times negative x. Positive 16x. Next thing would be to collect your like terms. And what is 91 minus 64? 27. X is on both sides. Which x should I move? Smaller one, the 16x. So subtract 16x to both sides. And what is 25x minus 16x? 9x equals 27. Divide both sides by 9, and what does x equal? 3. All of that work, and it's only half of the answer. Now to get the other half, go to the original. Do you want to use the top original or bottom original? Top. So 25x equals 91 minus 16y. Instead of the x, what do we replace the x with? 3. So this becomes 25 times 3 equals 91 minus 16y. And what is 25 times 3?
75.
75 equals 91 minus 16y. And what's next? Subtract the 91 to both sides. And what is 75 minus 91? Negative 16. And how do I get rid of the negative 16? Divide both sides by negative 16. And y is equal to 1. Write your answer as an ordered pair. Do you have questions?
No.
Okay. Write your answer as an ordered pair. And what is our answer written in ordered pair for? 3, 1. Don't forget to write it as an ordered pair.
Right,